always be there, but in here in Fs, you need to do the Laplace transform of f. Instead of ft, it will be Laplace transform of t plus t0. Okay, because then you need to ut only it is time shifting is done in ut. Okay, and this one is frequency shifted, so fs will s will be replaced by, because normal ft it is fs. So if time shifted, then frequency shifted. This one is frequency shifted. Then it will be fs plus a. Instead of fs, it will be fs plus a. And if single differential dft by dt, then what was the formula? Then s of fs minus f naught. This is for single differential. And when it will be double differential, then here at s square will come, and minus s of f dash naught 0, s of f0, and then minus f dash 0. So if it is n differential, then this function will be like this: s to power n minus 1, n minus 2, and then s power 0, the last term. And here this f0, this is f dash 0 means first differential, and then put 0 into that. Okay, so that is what we will do. And then here it is, the last one will be f0 only. So this way you can, but normally we will have first differential, second, or up to third only. So we can easily do this. And then t of ft is something which is the differential. The answer will be differential of this function. And how will you get this? So again, you need to do some, you know, differentiation of multiplication kind of. Okay, and if you integral, I already discussed, whenever we will do Laplace transform of integral, so we will get an extra term which is 1 by s. For first differential, for first integral, means one time integral, we will get 1 by s of fs. If there is no shifting, nothing is there, only the integral, then we will have this kind of function. For first, if the integral is one time only, then 1 by s. So this part I have covered earlier, and this one was covered. Okay, this is something somewhat new, that if t of ft means, normally we did either t or we did ft. So ft, for ft it is fs, and for t it is what it was, s 1 by s square. For 1 it is 1 by s, and for t it is 1 by s square. Okay, and for t square, what it was? For t square it was 2 by, means factorial n, 2 by s cube and plus 1. So it is like that. But what about t of ft? T of ft. So this one you need to do it again. Means here you can apply the formula for means it's a multiplication, integral of multiplication, and then you may get this kind of answer, minus dfs by ds. Okay, so sometimes it may be, so then we'll think of. So here this has been proved also, because this is, I said, this is somewhat which we have not discussed earlier. So you can see, normally what we do according to the definition of Laplace transform. So this you already know, that 0 to infinite ft e to the power minus st dt is nothing but fs. Okay, and if you take differential of both sides, so this integral will be removed. So ft will become a differential. Yeah, once you take the differential, so this will be what? This will be d of fs by ds. So this side will be d of fs by ds, and the Laplace transform of this is what, this is nothing but fs. Okay, this is nothing but fs. So d of fs is f dash s. This you know. We can represent d of fs. D of fs is nothing but f dash s. So it's just a representation of d of fs by ds by f dash s. Okay. So when you do this d of fs by ds, so this integral and differential of any integral is actual function, or because here uh, it is done like this, d by ds is taken inside it, and uh, and then differential of this function. How will you do the differential? So when you do differential with respect to s, d by ds with respect to s, so then minus s term will come out. So minus, uh, because it is with respect to s, so minus t term. The factor of s is minus t. So minus t term will come out into e to the power minus st. Okay, dt. So ft is kept as it is because there is no s inside it, and this differential is with respect to, just leave it. This is dt, but I am doing this part only. So in this part, there is no s term in ft. So this will treated like a constant, and this will be treated like a variable, and minus t will come out, and this one. So this one will be the answer. Okay, and this is nothing but what? This one, if you carefully look after it, just take minus outside. So this is nothing but ft of ft e to the power minus s dt. Okay, and which is nothing but, if we consider this as whole function, so this is nothing but t of Laplace transform of t of ft with minus sign. So it is nothing but minus L of, just we have considered this as a function. So this is nothing but, according to definition, the function into e to the power minus st dt 0 to infinite integral is nothing but Laplace transform. It means this is Laplace transform of t of ft. And what is left hand side? The left hand side is d of fs by ds. So it means Laplace transform of t of ft is nothing but d of fs by ds. So this is proved that if we will take Laplace transform, so we have not done it directly, like I said, that by integration of multiplication. Instead of doing that, it is easier to do like this. That first, first you should do whatever you want. So we want d of fs by ds in our function. Okay, d of s according to the answer. So we have just gone with the answer. The answer is that Laplace transform of t of ft is d of fs by ds. Fs definition we already know. So we have started from that, means with the answer. So reverse manner, and then we have tried to get this function. Almost all the methods are covered here, and this was already covered in previous slides. Okay, now let us do some examples in MATLAB, how to do Laplace transform and how to do inverse Laplace transform. So whenever, by default the MATLAB is in time domain, but if you want to convert that in frequency domain, so first keyword will be the shifting frequency. So for this the command will be what? The command will be syms is a command keyword, you can say, and t to s. So t to s means now it is ready to do Laplace transform, conversion of any time domain function into frequency domain. And the keyword for doing Laplace transform is Laplace only. Laplace, and the expression whichever you want, you should keep it inside the bracket, small bracket. Okay, and here the star is something which is representing multiplication. Plus minus have same meaning. Star is representing multiplication, instead of cross it is star from your keyboard, and plus is representing plus only, minus is representing minor, and power is represented by this. So this one is the notation for power in this. Okay, so how what we did, simply just use keyword SYMS. T to S means time domain to frequency domain, and then Laplace whatever function you want. So let's have a quick practice of it, and then we'll do reverse of it. SYMS from frequency to time domain. Okay, so frequency to time domain, and whatever you want. So now everything will be in form of S domain, and you will use keyword I Laplace. So I Laplace means inverse Laplace over here. So keyword for doing inverse Laplace is I Laplace. So once you will write this way, so you should know how to write the expression. For plus it is plus, minus it is minus, for multiplication it is star, and division and power it is cap, and for division it is slash, like this. So these are the major mathematical terms which you should know, and once you do this you will get the answer. Okay, so let us do, we will do it first of all the known expressions, so that we can easily understand that our answers are correct. So like Laplace, for Laplace what we should do, we should first convert, although it is one time, once you will convert then you need not to do it again. So SYMS TS, so it means now your system is shifted to frequency domain, time domain to frequency domain. Then Laplace, and any function, just keep any function inside. So let's do t square, t power, t square means t power 2. So the answer will be 2 by s cube, because factorial n, and factorial n means n here is 2, so 2 into 1, and divide by s power 2 plus 1 means s power 2 plus 1, so it is s cube. Let's do any other, because it is already shifted to frequency, so we can do any number, anything now for Laplace only. Laplace, and here it is e power, e power 2t. So I, what should be the answer? You know, e to the power minus 2t is 1. E to the power minus 2t is what? 1 by s plus 2. Okay, so sorry, I have not put star here. Here is star because multiplication. So star should be there. Okay. So something wrong over here. I think we should put some bracket exp. I think here it is. For exponential it is exp. Okay. E is nothing over here. So Laplace, we do it again. So it will automatically tell you some corrections also. 2t. still something wrong. Also, T is star is not there. So I hope this one is correct. Yeah, it is showing error. Star P. So I think some bracket and all is missing. Here I need to put some bracket. Again some bracket. 2 star P and cap should be there. Yeah, EXP is outside of bracket and power should not be there. Power is not, yeah, power is not required. So we don't need it. It's automatically showing that exponential 2 star T. Yeah, see, this is the correct answer because we know when e to the power minus 2t, so here power is not required. Exponential means here it is e to the power 2t. That is the meaning of it. So cap is not required to represent exponential. Okay, rest other places whenever power, so you should put cap over there. So here, because this is plus sign, so in this we are getting 1 by s minus 2. Okay, and if this is negative, then you will get, so here just put minus and let's see what is the answer. So this time we are getting, so this we already know, so first you practice with the known functions and then you can go ahead with some other functions. Like here something kept, like if t of exponential 4t. So you know, for t of exponential 4t means it is exponential 4t multiplied by t. So actually it is taking the formula for t only. The formula for t is 1 by s square, but it will be considered as frequency shifted function and s will be replaced by s plus 4. So that's why answer is like this. So you can check with this answer also what whether we are getting one frequency shifted function or not. So see, this is the correct answer. So you can check if suppose the question is very complex and it is time taking, so you can use MATLAB tool also to get the answer quickly. Now let us do for inverse Laplace. So again we will do something for known. Before that we should change it from frequency to time domain, s by ms, and frequency to, sorry, s to t. Okay, so now it is changed. You can do anything from Laplace to get back in time. Okay, I Laplace, and inside bracket we will put whatever we want to convert. So 1 by s. What should be the answer? It should be 1. So 1 by s, the answer is 1. Now it is already shifted, so you can do any inverse Laplace because it is already in from shifted from frequency to time domain. Okay, so here I Laplace and 1 by, let us do for 1 by s minus 2 and uh, power 2. Let us see. It is 1 by s minus 2 square. And let us see what is the answer for this. So actually, it is 1 by s square means what? It is t. For t only we get 1 by s square, but it is s minus 2. It means there is shifting of frequency. So how do shifting of frequency? Some exponential term e to the power 2, because why it is positive? Because here we are getting minus. So this way you can check for other cases also, that if any differential function is there, then what will be the answer. Okay, so this way you can check for. So I'm giving you few questions, you can practice with this. Here there are three functions given to you. I hope this is visible to you. You can open your MATLAB, you can use online MATLAB too, and you can do the conversions. And how will you do the conversion for Laplace? We can start with converting from time domain to shifting domain, and your question is this one. So I hope my questions are visible. T square e to the minus 3t, first question. Second is t square cos 5t. And the last one is t square sin 5t. So is this clear? Question is clear to you? Okay. So everyone, I hope you all are having MATLAB tool with you. You can use online simulator also. Online MATLAB simulator is available freely for the students. You can log in and you can do this. So you can do this uh, by sharing your screen. Okay. So I'm waiting for your answers. If anyone have done it, just put yes, type yes in chat box so that I can allow you for presentation. Anyone have done? Okay, let me share again. So here is the question. Uh, the question is ft t square e to the minus 3t and t square cos 5t and sine 4t. So anyone have got the answer? I'm waiting for your answer. Oh, why my screen is not visible. Actually, I am just asking. I know that you can do the calculation. I am just asking to show in MATLAB only. I want your answers in MATLAB simulator. Not here in chat box. You just only if you have done it in MATLAB, then only say yes in chat box if you have done in MATLAB. Do you know how have you used MATLAB? How many of you have used MATLAB tool? Online? You can use this. Go to this link, login. I mean, start using with your Google account. You can use this MATLAB online. This one. I hope my screen is visible to you. So just let me know the issue. Nobody is responding. Risha, can you please show the question again? Okay. Here is the question. This one. One, two, three. There are three questions. I hope my screen is visible. Is this visible? Just like I have demonstrated with MATLAB, you should also do the same thing in MATLAB. Anyone have done? Uh, Cassandra, have you done it? I'm waiting for your response. How will you do? Just simply open MATLAB tool. So you will get this kind of window over there, this kind of window over there, and then you can just simply start SYMS. It is T to S transformation, and then you can do with Laplace. Laplace is the keyword over here for changing Laplace from time domain to frequency domain, and for inverse Laplace it is I Laplace, but for that you have to first switch back to T, S to T over there. So the first question is T square e to the power minus 3t. You can use this example for your practice. Use this example for your practice. Let me type this in your chat box so that you can use this example for your practice. And then you can try with another expression. Any problem? Uh, can you share your screen? Yeah, answer is yes, answer is okay. Answer is correct. Can you share your screen? Yes, so T to S and correct. This is for first one. Then for cos it will be something T square. No, so T square cos 5T will be somewhat very complex because with cos T square will be somewhat very complex. So that's why you are not much clear about it. That's why I have given complex function, na? Which is difficult to do manually. You can easily do it in MATLAB. Okay, and you can try this manually also whether it will remain same or so it has multiple expressions also. So you can try this manually also, and then you can verify your answer. Because it's not that much clear. You can go with some known question and then you can practice over here. Now you can try with I inverse Laplace. So what will you do now for inverse Laplace? You just shift it S to T and try doing this question over here which is kept in the slide. Okay, so the writing expression is somewhat difficult, not as much difficult. If you know the format you can do it. So here I have kept the format for like division, multiplication, how to write all these. So this expression has been written in this form to take I Laplace, and I Laplace is what? So this function is quite complex. If you will try to do it manually, first you need to expand this in uh, separate the terms, and then only you can find out the standard forms. But if you will try this, means partial fraction of expansion kind of need to be done manually. But when you do it directly with MATLAB, you can easily get the answer. There will be somewhat mixed kind of terms over here. So you may get some cos function, you may get some exponential or time function. Okay. So here the question is kept for you. This is for practice. Answer is already given. And this one is for you. The Laplace transform of these terms. Inverse Laplace of these. Just try I'm giving you 5 minutes time and complete this question. I need answer from all. I have got only two answers uh, till now. So just quickly do it for inverse Laplace. Oh, actually my screen is not shared, so let me share my screen now. Okay, so yeah, so I hope my screen is visible to you. So this one. So now inverse Laplace transform to do it. So will convert from S domain to time domain. And first you practice with this known question whose answer is given over here. Okay. And then you do it with the question given right side, A and B. So it is somewhat complex when you try doing manually. So what you need to do in this question, you should first separate all these terms just by doing it partial fraction expansion, and then you will be getting the standard term which easily taken as inverse. But here, because it is MATLAB, so you can do it. Only you should know the format how to write the expression inside I Laplace. So the keyword for I Laplace is what? Inverse Laplace is I Laplace. Okay. So I'm waiting for your answers. Once it is complete, let me know. First, you should do this with known expression. The expression is this one, and then you should do the questions. And once it is complete, you can type your. You can just say yes in chat box. It is done. I want answers from all. So you are connect. How many of you are connected with laptop? And if it is possible with mobile, you can do it with MATLAB online in mobile if it is possible. I'm not sure because some of the tools easily you can do in mobile also. So online cloud-based things can be done in mobile. So I'm waiting for answers. So how many of us you tell me? How many of you are connected? Just type in answer yes in chat box. Let me mark your attendance first. Just say yes in chat box. So today is 25. So nobody is responding. Are you not doing it? You are not doing it. Any? NA. What about you? Yes. Can you share your screen? Let me stop presenting. Can you? Okay. So fine. So have you done other two questions also? That is for first.
Again po, ma'am?
So how many questions we did for I Laplace? I think you gives undefined situations like zero multiplied by infinite or infinite by infinite kind of situation where you cannot predict what should be the uh, answer. But if the same thing can be analyzed with the help of frequency domain, you can easily do. Okay, so that's why there is, if suppose you want initial value, so you can convert that into S domain and then find out the value, and you can easily get the answer in that case. So that's why there are two theorems. One is initial value theorem. Initial value theorem. So initial value theorem means value means when time is zero. The function value when time is zero. So the actually basic definition is limit t tends to 0, that is initial value, or you can say it is nothing but f0, the value of function at time equals to 0. But sometimes this, if you will directly apply the function is 1 by t and you are applying 1 by 0 over here, will be infinite, or if it is something like some different question you can put some different question. This one is very simple, so here it is clear that answer will be infinite. But there can be some kind of question where uh, the situation like 0 by infinite or something like infinite by infinite situation may arise. So in that case, finding out the initial value will become very difficult. And sometimes we need in doing calculation, we need initial value. So that's why this theorem says that if limit ft t tends to 0, so that can be also written as in S domain as S of fs, S of fs, where S tends to infinite. So here t tends to 0, but here t tends to infinite.
Ma'am,
Okay.
excuse me po. Are you sharing your screen po?
Okay, okay. Wait. So my screen is not shared. So I hope my screen is visible to you. Okay, so this one I am talking about this. So initial value theorem means you are trying to get the function value at time equals to 0. Means according to the basic definition, limit t tends to 0 for ft is nothing but the initial value of any function. Means f equals want to check the same thing in S domain. So it is nothing but it is S of fs where S tends to infinite. So instead of calculating this, we can also go with S domain. In if we know the value of Laplace transform, or if the function is already given, the transfer function is already there in S domain, so we can directly find out initial value by using this formula instead of this. So both are same. Limit ft t tends to 0 is equal to limit s of fs s tends to infinite. So when t tends to 0, s tends to infinite. Okay, so initial value. And Meaning of initial value means the value of function at time equals to 0, initial conditions, okay, in time domain. So let us do some questions on it. So suppose your function is this one, this is your question, okay, and you want to find out the initial value of it. So because in this question the function is already in S domain, so either you should convert in time domain and then get the answer at fg, because the question is to find out f0. So either you can convert in time domain, but converting this in time domain will unnecessary, it take time. So it's better to do it in S domain only. So if you are finding out in time domain f0, so what will be in frequency domain, then S tends to infinite according to the formula S of fs, where S tends to limit S of fs, where S tends to infinite, okay. And now put the value of function over here, the value of function over here, okay, and just spread s in this means first we will try to simplify that, and then we will put, if if t tends to 0, here t tends to 0, it means s tends to infinite. So if you directly put s tends to infinite, so infinite multiplied by infinite, and here it is infinite, so it will not be very much clear what will be the answer. So that's why simplification is important. Now you multiply here, so you will get s square plus 2s, and see the highest power of numerator and denominator. So what is the highest power? The highest power is s square. So what you do, you divide by highest power of numerator and denominator. So once you divide it by s square, you will get s square by s square, means this will become 1, and second term will be 2 by s square, and in denominator, when you divide it in denominator, so denominator is s square by s square, it will become 1 plus 2 by s plus 1 by s square, and plus 25 plus 1 means 26, so 26 by s square. So this will be your, after simplifying, this is 1 plus 25 is nothing but 26. So this function is s square plus 2s divided by s square plus 2s plus 26. Now you divide both numerator and denominator by s square, so you will get this function. Now you can put s tends to infinite. So if you put s infinite over here, this term will become 0. And infinite over here, this will become 0. This will become 0. So final answer will be 1 by 1, and which is a finite answer. And you are means which is means you can say it's not like it is a defined answer, not undefined, which you cannot say what exactly it is. But one means it's a kind of finite value, and the value of it is known to you. But if you will directly put infinite over here in this term, so you will not easily conclude that what is the exact value of the answer. So that's why somewhat simplification is required. This one is the correct answer for initial value of this function is what? 1. Okay. Now same thing you can apply for this question. So now the fs is 2s square divided by s cube plus 2s minus 4. And you have to find out initial value for this. So how will you apply the formula? Just write limit s tends to infinite s of fs. Okay, and now put the value of fs over here and start doing the same process I have applied over here. So is that clear to you how to apply this process? Once you put s of fs, value of fs, so here the maximum power in numerator will be 2s cube divided by s cube plus 2. So what is the maximum power in numerator and denominator? S cube. Now what you do, divide both numerator and denominator by s cube, and let me know the answer by putting s tends to infinite. Okay, so let me know the answer. What will be the answer for this question? This question, this one. The question is find the initial value of given function fs is equals to 2s square upon s cube plus 2s minus 4. Yeah, this question. You have to give answer for this question, and let me type this question in chat box if it is possible. In this is not a detailed image. So you can just do it. Anyone have got the answer? Anyone? What will be the correct answer for this? You can apply this rule. First, you put s of fs in limit where s tends to infinite. Okay, where s this thing where s tends to infinite over here, and uh, then multiply s by numerator and spread this on this and divide by maximum power of s in both numerator and denominator, and then put the value of s infinite. After solving it, put the value of s infinite. So anyone have got the answer? Okay. Are you getting my question? Okay, so one answer by Jenna and it is true. Let us check this answer. Okay, so see those who are responding, I am noting down your names also. So those who are not responding, you should also respond because you know these classes are online mode and your responses are very important and it has 20% weightage for overall grade. Okay, so class performance is equally important. So we were here. Okay, so in this, let me do it. What will be the correct answer? So here limit s tends to infinite for initial value. S of fs is nothing but limit s tends to infinite and 2s cube when you multiply it by s, so it will become 2s cube divided by s cube plus 2s minus 4. And if you divide by s cube, so limit s tends to infinite, s cube will be removed 2 upon 1 plus 2 by s square because 1s will be removed, cancelled out, and 4 upon s cube. And when you put s infinite over here, so this will become 0, this will also become 0. So final answer will be 2. So, so your answer is absolutely correct. Okay, so it was by Jenna, and others have also answered at 6:48. Yes, exactly. So Jenna and Paul, Lindsay, yes, answered. Fine. So your answers are correct. Okay. Now next question. Next definition is what? Final value theorem. So final value means what? As the name indicates, final value when t tends to infinite. Then what will be the response, time response of the function? And it is very important. Both the condition, initial value and final value, both are very important in control system. That whether in steady state the system is stable or not, and what will be the initial condition, both are very important in control system. So that's why initial value and final value theorem is very important, because sometimes finding out directly t tends to infinite from ft is difficult, instead of finding it out from the Laplace function. Okay, so if t tends to infinite, ft, that is final value. According to the definition, the function value at t tends to infinite means at time infinite. So that is f infinite, and when you convert it into s domain, so it is s of fs where s tends to 0. So here t tends to infinite, here s tends to 0 in final value theorem. So that is your final value theorem, and let us do it with some example. Okay, so here one example is already kept. You want to apply final value on this. Uh, this is yeah, this one is your function, and this is your function, and you have to find out the final value theorem for this, final value for this. So s of fs, put value of fs here. Okay, fs over here, and see, here I don't need to what will be the value if you directly put s infinite, because s tends to 0, sorry. Here the s tends to 0, so if you directly put s0 here, so this will give you 2, and here this will give you 2, so finite upon finite value multiplied by 0. So finite value multiplied by 0, any finite value to whatever it is, x multiplied by 0 is nothing but 0. So this is a finite answer, and answer will be 0. So here I need not to anything divide or multiply, because this is already in standard form, and when 0 over here, I can get a finite answer, and which is equals to 0 in this case. Okay, now we will apply same thing for this question, where the function is s plus 5 divided by s square plus 5s. So when you apply final value, so fs, how will you write it? Fs, s of fs, and where limit s tends to 0. Earlier it was s tends to infinite, but now it is s tends to 0. So limit this is equal to limit s tends to 0, and s plus 5 divided by s square. So now if you put s is equals to 0, what will be the answer? So if you put s0 here, so this will become 5 in numerator, and if you put s0 over here, so see here s square plus 5s. So in numerator, denominator it will become 0. So 0, and 0 divide by 0. So again it is undefined form. So it is better to take s form outside, s outside from this. So one s will be cancelled out from this. So one s will be cancelled out from this. So what will be the new function? The new function will be s tends to 0, and in numerator it will be s plus 5, because it was giving undefined function. That's why simplification is required over here. So s plus, when I have taken s outside, so it's become s plus 5 Is it question is clear to you? Okay. So take your time and tell me the answer for both. So there are two questions in it. For B, first you need to find out initial value, then you need to find out final value. And let me type your answer in chat box. Okay. So have you got the answer? Initial value is 1 and final value is minus 1 by 2. Anybody else have got the answer? Anybody else? Okay. So let us do it. Okay. Remaining. So let us check this question. So first we will check it with initial value. Okay. For initial value, s of fs limit s tends to infinite. That is value. So limit s of fs means s cube plus 2s divided by, I have multiplied s over there, and s cube plus 2s minus 4. Now what you do, you divide it by maximum power. Here limit s tends to infinite. So limit s tends to infinite, and s, when s cube will be removed, so it will be divided later. So it will be 1 plus 2 by s square divided by 1 plus 2 by s square minus 4 by s cube. So if you put s infinite over here, the answer will be 0 for these two terms. This one 0, this one 0, and this one also 0. So finally answer will be 1 for initial value. And what about final value? So final value s tends to 0 and s of fs. So s of fs, so if we put 0, so what will be the answer here? Uh, so S of fs both are having same similar kind of same. So, so if you put a 0 here, so 0 plus 2 into 0, so numerator will be 0. Will be 0 plus 0 minus 4. So divide 0 by minus 4, which is a finite value. 0 minus 4 is anything multiplied by 0 is 0, because this is finite value, so answer will be 0 only. So here the correct answer for this is what? Minus 1 by 2. 1 is okay. Minus 4, so minus 4 by s cube. No, first one that is correct. What about second one? So s of fs, s cube plus 2s, and s is also not going to cancel out. So be 0. Most of you are giving same answer. Can you justify your answer why you are getting minus 1 by? According to me, s of fs, and there is no simplification possible. No further simplification is possible. So we are not going to multiply or divide anything over here, and here the answer will be 0. Have you checked again why you are getting minus half for this question? Have you done okay? You have done part A. Okay, okay, part A. What about part B? This your answer is A or part B? Uh, I because there are two questions. Question one. Let us check for question one. For question one, if I put s of fs, so s square plus 5s and s square by 5s. So answer will be 1 for initial value. And what about final value? Because both become same now, numerator and denominator. So initial and final value will remain same because the function is after multiplying by s it becomes 1. So for a it is 1, initial value 1, and what about final value? Purpose. So in that case also 1 comma 1 and 1 comma 0. According to me the answer is 1 comma 1 and 1 comma 0. But most B it is 1 comma 0. And what about A? Initial value A, final value does not exist because theory applied. Why it is so? Jenna, why this answer final value does not exist for B? But I have just now shown you it is nothing but 0 upon 0 plus 0 is 0. So 0 upon minus 4 means 0 into 1 by minus 4 is nothing but 0 multiplied by a finite value. The answer will be 0. So it's a defined value. I hope for B. So for B, the correct answer is 0 for final value and initial value is 1. So that is the correct answer, Trisha. And for first half, minus half is not the answer in any case, even if we consider A, part A. So I think I have already shown you the initial value for part A will be 1 only. And for final value, again s of fs, you will do s of fs. So this numerator becomes denominator. So again it will give you a constant answer 1. So answer will be 1 comma 1 whether it is final or initial value in this case. Part A. Okay. Wait, let us do some other questions. This is a calculate. This one is related to calculating transfer function. Okay, so let us do this question. It is not related to initial value or final value. Okay, let me give you one more question. Start of this, let me give you one more question so that if any confusion is there, that will be clear. So, this question. So my next C, and this is question of S. Question is 5 upon S into S. So suppose this is my question and you have to find out, let me make it somewhat bigger. Okay, so this is your question. Okay, this is your question. The question is Fs is 5 upon S into S minus 2. This is your question and you have to find out initial value as well as final value. The question is clear. The question is this one. You have to find out for C. initial and final value for C. Everyone try this question, and through this you will be able to remember the concept of initial value as well as final value. So initial value S of fs, S tends to 0, find the value of it, and final value S tends to infinite. For initial value S of fs, S tends to infinite for initial value, and for final value S of fs, S tends to 0. So do it one by one. There are two answers, for first for initial value and another for final value. So for initial value S of limit S of fs and S tends to infinite. First you find this, and second limit S tends to 0 S of fs. So this one is your initial value and this one is your final for this question C. So anyone have done this? Anyone? I'm waiting for your answers. So anyone have got the answer? So initial value is 0 and final value is minus 5 by 2. I hope this answer is correct. Uh, 0, 0. Check. I will check. Let me note down your names. Okay, so I noted down your names, and I hope some of you, the first answer initial value is absolutely correct, and second answer minus 5 by 2. I hope this is correct. So let us check it. So if you multiply it by s, so ss will be cancelled out from here. You can see fs is having s. So if you multiply it by s, if you will multiply it by s, ss will be cancelled out. And if you put s infinite over here, so 5 by infinite minus 2 is nothing but infinite, and 5 by infinite is nothing but 0. So first answer will be 0. When you put in this, if you will put 0, so if you put 0 over here, if you put 0 over here, so it will be minus 2 and in numerator 5 is the correct answer. So many of you have given correct answer 0 2. So I hope this is clear to others also who have not done it. Okay, now we can start with this, which is a new thing. Means if any circuit is given, so how to find out the transfer function for that circuit? Because here you have to find out the transfer function. Transfer function I already told you, it is nothing but ratio of Laplace transform of output upon RC circuit, and it is not new to you. You already know RC, RLC, this kind of circuit, and the property of resistance and capacitance in the circuit. So when the resistance, so it will have a drop which is nothing but equal to I into R. So what we do, whenever such question will come, circuit, you should consider the current, a variable which is IT, and IT is the current flowing in this loop. Okay, so here I is flowing in R as well as in C. So when you will apply on loop over here, KVL in this loop. So what will be the answer? Total voltage applied is nothing but drop in resistance and drop in capacitance. So drop in resistance is nothing but R into IT, and drop in capacitance, we will go with the definition of capacitance. So you know definition of capacitance is nothing but Q equals CV, and you know dq by dt is nothing but C dV by dt, and dq by dt is nothing but I. So I is equals to I of capacitor is nothing but C dV by dt. So what about the value of drop in C? So you can just take dt this side. So dv is nothing but uh, 1 by C I dt. So what you can do, you can take integral of both sides. So voltage drop is nothing but integral of voltage drop is nothing but 1 by C is constant integral of I dt. So the same thing has been written over here. The mesh total applied voltage is nothing but drop across resistance and drop across capacitance. And drop across capacitance I have just proven here 1 by C I dt. So I hope this is clear. So this one is equation 1, and equation 2 is drop across capacitor, which is the output, and drop across capacitor is this one. Okay, now what you can do, you can take Laplace of vis and take Laplace of vos. So Laplace of vi is nothing but r into it. So it will give is and r is a constant, and when you do uh, Laplace of any integral, so you will get a function 1 by s of this. So 1 by c is already there, and I will become it will become is, and 1 by s will come when you will do Laplace of integral. If you remember, the Laplace of integral, one s term will come in denominator. Okay, and r is a constant, I will become is after taking Laplace. 1 by c is already there, and integral of i integral of I dt will be nothing but is upon s in, and 1 by c is already there, so you will get this term. And what about vos? So vos is this one, so it will be nothing but vos is 1 by same term will be repeated over here. Now from this you can find the is. So is is nothing but sc vos. Okay, sc vos, and put this is value in this, so you will get the relationship between input and output. Now from this, just divide it by uh, VOS. So you will get VIS by VOS, and then take inverse of it. So you will get this answer. So just by simply just take VOS this side. So it will be become VIS upon VOS, and SC up, and you just solve this. So just take SC outside. So it will become 1 plus SRC, and SC will be cancelled out. So 1 by it will be numerator. So you will get 1 plus SRC is nothing but VIS upon VOS. So what will be VOS upon VIS? VOS upon VIS will be inverse of this 1 by 1 plus SRC. So this is your transfer function which is asked. So you can, in control system, you can write it as that the forward gain is SRC, and the output is VOS, and input is VIS in terms of control system. Okay, so this way you can represent, and here this one is your transfer function. VOS upon VIS is nothing but 1 by SRC. So this is for RC circuit. You can easily use the concept of R and C. Sometimes it is RLC circuit, so you should remember the property of inductor over there. Okay. So here are some table which was already covered, like delta t is nothing but the Laplace transform of delta t, just for your revision, is 1. Ut means the constant value 1. So whenever you take Laplace of 1, it will give 1 by s. And for t of ut is 1. Ut is considered as 1. So it is nothing but t only. And for t, the Laplace transform is 1 by s square. T to the power n, ut means t to the power n. So what will be factorial n upon s upon s power n plus 1. And this is what frequency shifted function. So ut 1 by s, the answer for ut is 1 by s, but it is frequency shifted, so that's why it is 1 by s plus a. and this is nothing but sine function. For sine function it will be omega upon s square plus omega square. For cos function it is s upon s square plus omega square. So that's why I have kept this in this slide so that you can remember all the rules which we have discussed till now. This is final value and this one is what? Initial value theorem. And Laplace of any integral is nothing but fs by s, and this one is for differential, and this is what? This is time shifted function, this one is frequency shifted function. And if you will spread Laplace on any equation, so it will be linearly spread on, means you can Laplace of sum of any function is nothing but uh, sum of their Laplace transform. Okay, so f1s into f2s you can simply write, and if you will take Laplace transform of constant into function, so constant will come out and function will be converted into Laplace transform. So different, the name of this one is the definition of Laplace transform, that if you want to take Laplace transform of any function, so you can integrate it from 0 to infinite. 0 minus is representing just the value when it has started. Okay, and ft e to the minus st dt, and all these theorems here. This one is linearity theorem, and this is frequency shift, time shift, scaling theorem. Because if you are taking Laplace transform of function of at, so it will have this kind of answer. You can check it whether it is giving same answer or not. And this is for differential, integral, and in final value and initial value. Okay. Now next thing is partial fraction expansion is another math, is a technique to simplify any transfer function. So because sometimes we need partial fraction expansion to get the inverse Laplace transform, because if somebody will ask you inverse Laplace transform of this, so it is not in standard form. So first you need to convert it in standard form. So how will you convert that in its standard form? So if numerator power is higher than denominator power, so first you should divide it. So here we are just simply doing division, and once the numerator power is equal to less than denominator power, then we can stop over there, and then we can further see that whether this is in standard form. If it is in standard form, it is okay, otherwise you need to do further simplification of it. So the Laplace inverse of s is nothing but the differential of what impulse function, because S of Fs is for Ft. But what about S? If S is there, it means because the Laplace transform of delta t is 1. Okay, delta t is 1. But if d of Ft, if you will take Laplace transform of d of Ft, so it will give you S, because when you apply the formula S of Fs, Fs is what? 1. So S of Fs is 1, so answer will be S only. So for S, the inverse Laplace transform of derivative of delta t. And for 1, you already know that delta t, the Laplace transform of this function is 1. The Laplace of this function is 1. 1. So it means for 1 it is nothing but delta t. Inverse we are doing inverse. Na? So for 1 it is delta t. And what about this? So this is something which is in form of what? Sine function. Let us check. Sine function is having constant in numerator. So if there is quadratic function in denominator and constant in numerator, it means it is sine function. So how will you convert this in sine function? But this is not in standard form. So first you should make this in standard form, then only you can do it. So how will you make? You can apply some rule of mathematics of whole square. So you can write this in form of frequency shifted function, so you can easily do it. Okay, but here it is not further simplified in this, but you can do it using some technique like s square plus, you can rewrite it as 2 upon s square plus 2s plus uh, how will you make it in standard form? So I have to make this in standard form, no? So we can do it like this. Here, this one. First, we will try to check whether it is possible to do it in factor or not. Is there any factor possible? So yes minus s is s only, but yes factor is not possible. So what we can do, s plus half. The whole square of s plus half is nothing but s square plus s plus 1 by 4. It means you can rewrite this expression as s square plus s, and 5 you can divide it as like 1, just subtract 1 by 4 minus 5. 5 minus 1 by 4, what will be the answer? 19 by 4. uh, 19 by 4. So you can write this as 1 by 4 plus 19 by 4. It will be nothing but 20 by 4, which is 5 only. And now this is what? This is nothing but, I have just rearranged. And so we can rewrite this as 2 upon s plus half whole square, s plus half whole square uh, plus 19 by 4. Now this is time shifted function, and this is what? This is the constant. So you can rewrite this as under under root 19 by 4 whole square. So you should here in your numerator there should be a constant term which is 19 by 4 upon 19 by 4, means multiply and divide it, so that you can make it in standard form of sine function. So you will get a sine function which is shifted in time frequency domain by 1 by 2 by 1 by 2, and the omega value is what? Omega value here is 19 by under root 19 by 4. So this way you can solve and you can get the inverse of it directly. Okay. So finally it will be frequency shifted function means e to the power minus 1 by 2t, e to the power minus 1 by 2t into sine. Omega value is under root 19 by 4, 19 by 4 into t, and and 2 by, and 2 by under root 19 by 4. So this way, because why I am dividing it? Because in numerator you should have omega. So if you are converting it into sine, it means you should divide by omega also, multiply and divide by omega in the, so you will get this kind of answer. So either if factorization is not possible, so you should, it is a quadratic equation, so it may be in cosine or sine function. You have to arrange it in standard form. Okay. Now if it is possible to factorize, or it is already in factor, like here there are two factors of s is equals to minus 1 and s is equals to minus 2. So in this case you can do the this method to partial fraction expansion, and in this we will apply the rule of fraction expansion, and you can separate this like here, and once you separate this will become in standard form. But how to get the value of k1 and k2? So this is a mathematical process that you can rewrite this equation as k1 upon s plus 1 and plus k2 upon s plus 2, and you don't know the value of k1 and k2. So how to find out the value of k1? So k1 can be found by just putting remove s plus 1 from here, means limit, and put the value of s equal in this. Okay, if you want to get the value of k1, so just remove this term from this and put this. So if you put minus 1 in this, so this will become plus 1 and answer will be 2. So k1 value will be 2, so 2 upon minus 1. What about k2? So for k2 we will take this term and remove s plus 2 from this and put minus 2 over here. So when you put minus 2 over here, this will become minus 1. So minus 2, final answer will be minus 2 divided by s plus 2. So this way. And now this is what, this is frequency shifted function. This is what e to the power minus t. Na? If you will take 2 into e to the power minus t, and this will give you 2 into, no, this is what, plus, correct. And 2 into e to the power minus 2t, and ut is optional. Ut is something which is 1. Okay, so you can write it as ut. 1 means ut and ft. So ft, because everything is t, so you should write it in this form. So this is the final answer of inverse, means from transfer function. If you want to find out the time domain function again, so you can do partial. So why do we need partial fraction expansion? Because whenever we want any inverse Laplace transform, so in that case, getting inverse Laplace transform for this directly is not possible, because this is not in standard form. So you need to first convert the standard form. So all the tool which you have studied is in mathematics, you can apply over there to make it in standard form. Like here I have did it in different manner. Here we have divided it by denominator, and then after getting numerator power less than denominator, then we have tried to make it in standard form. But if this kind of situation where numerator is already having power less than denominator, then you need to check whether the factorization is possible or not. If it is already in factor form, then you can do partial fraction expansion. Okay, so this is about. Now you can practice with this question at your home. Okay, so wait, let me type this question in your chat box so that you can practice with this. Okay, okay, let me type this question in your chat box. Your function fs is, let me give you some question, 5 divided by s plus 3 s minus 2. You have to do, yes, same question. Oh. This is your question. You have to find Laplace inverse for the given question, and practice with this question at your home. Okay. Or let me give you one more question. Some different question over. Yeah, question is clear to you? Question is clear to you? Let me give one more question. Fs is equals to s plus 1 s plus 1 divided by s plus 2. So you have to find out the inverse Laplace transform of this. So here again you need to think what is possible to make this in a standard form and find the inverse. So I have given you two questions. Question number one is fs 4 by s plus 3 into s minus 2, and is equals to s plus 1 upon s plus 2, and you need to do it using whatever the mathematical method, whether it is partial fraction or division or something like that, to make it in a standard form, because currently it is not in a standard form. So you have to solve these two questions and get the answer. Okay, so is that clear? Question is clear to you? Question is clear. You have to find out Laplace transform of fs is equals to 4 upon s plus 3 into s minus 2. Second question is fs equals s plus 1 by s plus 2. Okay, and then we will discuss the remaining problem in next class. Although there is one more thing which is in next slide, which if I can quickly cover up, then I will do it. Like this kind of question, this one is very simple question, because in Laplace transform, if you remember, initially I told you that when we are going to evaluate for what transfer function, when then we do not consider the initial conditions. So you know, when you take the Laplace transform of any differential, so for the second derivative your formula will be s of fs, s square of fs minus uh, f dash 0 and minus f0, this formula. But if we will not consider initial conditions, so these two terms will become 0 and your answer will be s square fs, and the same has been used over here. So suppose you have to find out the inverse Laplace transform of this equation, so how will you do it? So inverse Laplace of this is what I have just assumed, that initial conditions are 0. So it will be nothing but s square ys, because here instead of f it is y. So y will become ys, and because this is second derivative, so s square will come over there, because we have assumed the initial condition 0. So these two terms will become 0. And when you take Laplace of this, so it will give you s of fs minus f0, but f0 will not be considered because we don't want initial condition. By neglecting initial condition, we can remove this term. So if you don't want this, so your answer will be s of fs. So s of ys, 12 into s of ys. And what about this? It will be 32 ys. So now it is converted into transfer function. So whenever we want transfer function ys into ys with respect to input ut. So it will be nothing but 32 by, just take ys outside. So it will be s square plus 12s plus 32, and it will come in denominator. So s into this term, and ys will be in left hand side. So this is your transfer function. So this way you can find out transfer function of any equation also, which is in differential form or normal form. Okay, and now this function is already achieved, and you want to get the time response time domain function again, because this is not this one analyzing this is not easy. So that's why we converted into Laplace transform, and after getting this, and we are able to factorize it, because here the factor is possible. 12s can be converted into like 4s plus 8s. 4 plus 8 is 12, and then you can factorize. And further, here you can apply the rule for partial fraction expansion. Okay, so this I will discuss by next class, and I have already given you the question, so you can practice with that in at your home. Okay, so I hope this is clear. So by this I am going to close this meeting now. Thank you very much.